Welcome to the third section of this course, in which we will dig deeper into OpenCV and use computer vision to build our own hand detector application. This app will be able to detect the presence of a human hand and outline its boundary as well, as shown in the picture. It will also be able to highlight the locations of the fingertips as well. So we will develop a library of functions, an API of sorts, to help us do this. And using this library, we will build an app which can translate our hand motions into on-screen handwriting, which will look something like this. So in the first video of this section, we will learn about skin segmentation and use it to extract the hand from the video. To do this, we will learn a few concepts like histograms, back projection, and also a few techniques on how to remove noise and clean the video. In order to detect our hand, we will first need to extract the areas of the video where our skin is visible. To do that, these are the steps which we need to follow. Step 1 would be to compute a histogram of the hand or the skin and store it. Then read each frame of the incoming video stream, and for each frame, we will use the previously stored histogram and apply back projection to the current frame to segment out the parts which contain skin. So what are image histograms? On a very high level, a histogram is a graphical representation of the color distribution of an image. It plots the number of pixels in an image which correspond to a particular pixel value. Let's turn our attention to the image on the right. Assume we have a grayscale image. If we plot a bar graph of the histogram, it might look something like this. There may be 10 pixels in the image, whose values lie in the range from 0 to 50. There may be 15 pixels, whose values lie in the range from 50 to 150. There may be 25 pixels, whose values lie in the range from 150 to 200, and there may be around 21 pixels, whose values lie in the range from 200 to 255. These ranges of pixel values are called bins. So we have computed this histogram with 4 bins. So the histogram of an image which contains a lot of skin will have a high number of pixels with the value which corresponds to skin color. Now assume we capture the histogram of an image which looks like this, a plain blue image. We can use this as a model histogram and use it to find the areas in a new test image which has the same color distribution. In other words, the output image will only have our object of interest with the similar color pattern. So if we use the previously computed histogram of that blue image and use it to apply back projection on this test image, we can get a resulting image which looks like the one on the right. We have completely segmented only that part of the image which was similar to the image on which we calculated the histogram. We can use this exact same technique to locate skin as well. The only difference being that we will first have to compute the histogram of skin.